Hello, everyone. We have Paul Barba, Chief Scientist, standing by to begin his presentation. Please take the stage, Paul.
Great. Thank you so much, Pamela. Good afternoon, everyone. Good evening, good morning, whatever it is, wherever you are. Thanks for coming to my talk. I'll be discussing debiasing contextualized word embeddings for NLP, debiasing pre-trained language models, sort of pick your jargon. This is me. These are places you can reach out if you want to talk to me further. I'll stay in the chat for answering questions, but I could talk about this stuff for days, but I won't. We've got a time limit here. So continue the conversation if you'd like. I will skip over the slide. It's here for the slide deck, but I'll just get into it. And before I begin, thank you to the UMass Amherst Center for Data Science. Thank you to the Northwestern University Business School. These are both organizations we work with. If you're in industry and aren't currently engaging with your local universities, I recommend these ones. It's been a great chance to, get to know students who might hire in the future, get to keep up with cutting edge research, get to collaborate. So the work I'm going to be presenting today came through the industry mentorship program with UMass. They provide 3 master's students, a PhD student. We provide a problem of interest to us in industry. We work together, try to get research papers, open source code, that sort of stuff produced. So thank you especially to the students who made this talk possible. All right, what are language models? Let's dive into it. I'm going to guess most of the people here are familiar with this technology. It's pretty common. This is a fairly technical audience, but just in case, get us on the same page. Language models are a very popular cutting edge approach in natural language processing. The core idea is that if you predict which word is missing in a sentence, the boy hit the blank over the fence, get a network to predict, penguin, and then you say, no, it's baseball. And it goes, okay, let me update my weights. Let me try to predict that next time. It turns out this produces a really rich representation of language. To predict missing words, you need to know a lot of grammar. You need to know about word meanings. You need to know common sense knowledge of the world, this, that, the other thing. So by taking gigantic corpora, 80 gigs of text, gigantic models, lots of time training, you're able to produce networks that encode a lot of information. And then if you use these as a jumping off point to solve NLP problems that you want to solve, you start a lot closer to the goal. And so therefore, with less data, you get more accurate results. If you look at the leaderboards for NLP tasks, it's probably dominated by language model approaches. If you hear about it in the news, GPT-3 or BERT, it's probably a pre-trained language model. And this is really interesting to me, as chief scientist at Lexalytics. If you're not familiar with Lexalytics, we're a natural language processing vendor. We've been doing this forever, 20 plus different languages, all different industries. Basically, if a business has problems involving text, we want to be able to help them. This is everything from voice of the customer, voice of the employee, pharmaceuticals, finance, it's a little bit of everything. So because of that, we need to be able to rapidly iterate, rapidly solve problems. Generating training data is sort of the bane of my existence. Any technology that promises to do better with less is super important and super interesting. We've been following pre-trained language models from the beginning. We've got them integrated into our system. I would like to use them everywhere, but unfortunately, I can't. And that's because of this slide, or slides like this. To describe what you're seeing quickly, the circles are quote-unquote black names. The pluses are quote-unquote white names. And as you move sort of left to right, you're seeing a shift in sentiment, in the association of just the name to positive or negative words, right? So taking a sentence, replacing Jacob with Deshaun is going to shift the sentiment quite dramatically. This is a huge issue. I can't possibly ship a model that uses this technology that has this sort of behavior, right? And run it across 1 billion documents, across all these different customers of ours. Anything that involves people in a sort of fundamental way, these language models just currently aren't appropriate for. They show this bias both with race, with gender, with sexual orientation, with religious views. These are all terms that they're bringing existing social biases towards. And this is a real limitation on where we can use them. Hence the work with UMass and debiasing. How do we remove this behavior? So to remove the behavior, we have to start from, well, where's it coming from? And it turns out there's sort of 3 sources. So I talked about these are usually gigantic corpora, 80 gigs of text, taken largely from the web. There's some overtly awful content on the internet. This is a sad fact of the world, but it is true. So some of it is learned sort of explicit bad behavior. Again, the language models are predicting missing words. They aren't trying to model, is this true, is this good? It's just what would somebody tend to say in this sentence. Second, there is what I would call sort of factual biases. There are biases that exist in the world that maybe we don't want to perpetuate in the future. And the best example of this is sort of gendered occupations, right? So the chairman of a board is less likely to be female. Nurse is more likely to be female. This is a true statistical distribution in the world. And so the models learn that, and therefore they reflect that idea that if I see the word nurse, it's more likely to be a female. Again, this is something that the way the world works today, but you wouldn't want to be making hiring decisions on that, right? I don't want to feed a resume in when I'm trying to hire a CTO and have it throw out, oh, you don't need to interfere with the women. They don't usually get these jobs anyways. No, that's something we're trying to change as a society. And then finally, there's just these interesting, subtle, subconscious biases. And I'm not a sociologist, so I'm not going to venture a guess about how much of it is believed versus just patterns we pick up as humans. But these phrase lists are from a project we did with a customer, analyzing their employee reviews. They were interested in whether they were being fair in their hiring practice, or in their promotion practices, rather. Were they promoting from the management level to the executive level fairly between men and women? A lot of the sort of superficial signs in the employee reviews were pretty balanced. Do they need improvement? Are they doing excellent? But we were able to quickly find that, for example, the center phrases were very different for men and women. The male terms tend to be more sort of strong language, significant, excellent, sort of generic positive words. And females are being complimented for stereotypically female traits like efficiency and patience and compliance. So again, this was, professionals in a professional workplace. I don't think that they were an overtly sexist organization, but these subtle language shifts show up. And then the models learn from this. And this is their one view into the world. So they learn to associate all these terms together, and all these terms of femininity, and all these terms with stereotypically female jobs. So the bias exists. These are the sorts of places it comes from. What can we do about it? And so this slide is just a sort of high-level overview of where research is being done. This is an active area of research. Students for a large sort of paper review to see what's going on. Any of the major conferences will have papers on this every time they come out. But basically, you can kind of break down where this is happening. Let me pointer here. I want to talk about the different sorts of approaches. So over here, we have your data for your pre-trained corpus. This is a giant corpus that's maybe problematic. Anything that improves that is a really promising approach, right? Because improving the raw data, if the data isn't bad, then that feeds into models that will not be as biased. This can be identifying problematic documents. It can be rewriting documents to be more neutral. It can be training people to write content better, teaching each other about bias and how this shows up so that we create better language in the future. Anything that improves that raw data is always a really promising way to approach a problem. Then we train a language model. Here, adversarial learning comes into play. This, deep networks are so good at picking up subtle clues, and it's hard for us humans to always find what they're doing, then maybe we can use it against itself. So you train another network to identify things like gender or race, and you sort of penalize the model to the extent that these are discernible features. There was a fair amount of work on sort of, can we just identify the dimensions where this is happening and then sort of rotate or just mathematically remove the bias? That doesn't seem to actually be very promising in practice, but it is an area of research. And then we were focused on improving the language model itself, but you can do all these same things when you take your training data and try to train a sentiment model or email routing or whatever it is you're doing. Then over on the right, you should always be looking, are we actually reducing bias? Are we reducing bias with different metrics? Anything you optimize will probably go away, but there's often a pushing down on a rug with a bubble effect where it can pop up somewhere else. And then it was really important, and this doesn't always happen in the literature, but to see, are you losing anything as you're changing these networks? So making sure you're monitoring both the tasks you want to solve at the end of the day, and just generally sort of diagnostic approaches to seeing that your models are still performing well. Let's go. So yeah, that was sort of the overall look at the areas that people are trying. The students in particular were focusing on the augmentation. So I said this is active area of research. Why is it so hard? Why is it active? Why can't we just sort of solve it? First of all, there was a really good paper recently, last year, called Lipstick on a Pig, about how simple mathematical approaches often hide the surface bias, right? It's not immediately visible, but the deep networks have no problem finding it again. Basically, there's a whole bunch of different language that we just saw earlier around femininity versus masculinity, around each of the different races. And so simple approaches that sort of remove the he minus she vector or something like that don't actually address that sort of second order, oh, from the word choice, we can tell this person was female. The data sets are very large, so we can't necessarily review them manually. It's more language than you can read in a lifetime. And even if you did fix it, you would want to keep fixing it forever because the world changes, right? We don't want to lock in, oh, great, here's the corpora all fixed as of 2020, because 2030 will be a different decade with its own language and its own things. So it would be nice if we could fix all the data, but I don't think it's very realistic. And then language is subtle, the bias is subtle. There are certain types of this that you can remove. You can sort of randomize names and stuff like that, but it's not clear how to rewrite every sentence to be sort of unbiased. So it's just inherently sort of a hard problem. So a little bit about the work the students did, and I thought this was pretty interesting. Right at the start, what they were doing was, let's see if we're removing bias. Let's see if when we hide a name, the algorithms can still detect the gender of the name. Now, doing nothing, which meant pronouns were still there, family relationships like sister were still there. There was a lot of very explicit clues, but 97% of the sentences, a model could be trained that would tell you whether it was a man or a female that had been hidden in a sentence. And then down below it, we have sort of after a lot of their augmentation. What they were doing is they were trying to remove explicit gender clues from the training corpus and then see if retraining Elmo, BERT, any of these algorithms would then remove some of this gendered knowledge. So you can see that it replaced Mr. with a generic prefix. Sister became sibling. We used gender neutral pronouns. So we were rewriting the documents to be less explicitly gendered. And there was still 14% of the time that you could detect that it could correctly predict the gender. This is often going to be things like job, nurse is more likely to be female. So that wasn't gone. I think some of it was biological. Anytime you talk about pregnancy, it's a pretty good guess what the gender of the person is. And I think the remainder here was just these sort of second order, oh, these languages tend to get used around males versus females, or these ideas or these concepts. So this was both promising. A lot of the gender information was gone, but not complete. There still seems to be more work that needs to be done. And the last point here, the last bullet point, GLUE is a pretty standard NLP data set. It does a whole bunch of different tasks. It's one of the ones that people compare algorithms across. We lost 1.5% of accuracy using these techniques. I think this was largely around pronouns. The fact that, Mary and Bob bought a condo, he loves it. You know that he refers to Bob because of the genders of the people. Once you anonymize the genders of the pronouns, you no longer have this connection. So it's having trouble sort of going sentence to sentence and understanding who is being discussed. What I thought was important here was 1.5% is not a big deal at the end of the day, right? This would still outperform older techniques. So it still shows that there is value in these approaches, that bias can be removed without removing general knowledge. We thought this was a really important thing to confirm as you're going down this path, because if you produce a model that doesn't work, there's really not much point. It's not biased. So here's something from the students' work. This is after a single iteration through the whole training set. So they were doing Elmo. This uses 10 EPOs, I believe, 10 passes through the training set as it trains the model. This is looking at job titles in male or female contexts, and then looking at how they differ, and then using PCA to sort of identify the dimensions that they differ on. And you can see that immediately sort of gender distinctions start showing up. The representations of CEO, when you're talking about a man versus a woman, are distinct points in these sort of high dimensional space. And after all their changes, you can see on the right, the points collapse together. And we were really excited. This was very promising. It looked like we were sort of solving the problem. Interestingly, by EPO 9, and I think somewhere earlier along the way, the gender distinction had resurfaced. And that kind of gets back to this idea that a lot of what you end up doing hides obvious gender clues, but the fact that it's influencing so many different facts of the world and about language choice means that it's not the first thing the model discovers, but it does eventually discover it. We thought, do we recommend people only train for one iteration and just suffer the lower accuracy? Probably not a good solution. But this is sort of showing you the challenge, that you could sort of delay the algorithms from finding this information, but that it did eventually show up. And these same sorts of things would happen along racial lines as well. So a couple kind of, miscellaneous things I thought were a little interesting from the project. One was that salesperson, for example, turns out to be a female term. Same with firefighter is more female than fireman. I thought this was kind of just interesting that as a society, we tend to still fall back a little bit on the male versions of jobs, salesman, chairman of the board. And then when we're talking about a female, that's when we remember to, chairperson. So there was some interesting, gender clues in the data set. Words are often also names and vice versa, will, may. So again, early work was really promising by the students. It was having a lot of trouble finding biased or finding gendered information, but it turned out the networks were just hopelessly confused. They had rewritten any name they found in Social Security data, and it turns out lots of common words are names. The network was just failing overall, but it looked very promising because that included the ability to tell the gender of terms. And then finally, Social Security, the baby name list. It's a really amazing resource. It goes back hundreds of years. It has frequency of names, gender of names. Racial markers, ethnic markers are a lot harder to find. There seem to be data sets, people do track this, but they aren't so freely and widely available. So the students ended up focusing on gender in particular because it was such an easy task to find strong clues for it. It permeates language so much. But removing all the other sources of bias requires more effort. So, recommendations, conclusions. And this first one is the most important, I think, to take away from almost any machine learning, any AI talk, is to be careful and to think about what you're doing. I think especially when we're starting in sort of an academic mindset and trying to sort of show that certain algorithms work, it's very easy to get very just caught up in how do I optimize this task. But once you want to start applying it into the real world and using it in real business cases, affecting other people's lives, for AI to be this amazing transformative tool that I think we think it can be, and we're trying to make it be, that means its impacts, that its decisions are going to have impacts. And that's bias. That's how is it going to do on out-of-domain examples. There's any number of questions, adversarial examples, that you just need to be cognizant of as you apply these techniques in practice. So I always get back to that idea of, be responsible, be professional, use these tools in a manner that is appropriate. Then if you're interested in this topic, I can point you towards some good research papers, but I think data cleaning is a very promising area of exploration, of research, how can we make the data itself better. And then adversarial learning is a little complicated. You have to worry a little bit about it seeming like it's removed bias, but not. But I think that's another important part of the solution. So I think, those are areas that I find interesting for continued work in this field. You should always look for bias in a lot of different ways if you're trying to track it. You should go all the way out to the final outcomes, which you're trying to measure, see if that's correlating with target classes like gender. Anything that you try to fix, anything that you train the networks against are going to probably be removed. But sometimes these things just pop up other places. We're looking into language models. How do we fix the language models so the bias isn't already there? You can also, when you're training your final models, apply these same sorts of techniques. There was a talk earlier today about using adversarial learning to hide protected classes as you train your specific model for your specific task. So I think this is a good problem to sort of bracket. We're trying to come at it from the early stages. How do we train the language model to not be biased? How do you remove the bias at the end of the day is also important in the way you approach it. And it's one of those that's solved from both directions. And then finally, this seems promising. The gendered reduction did happen with marginal impact on accuracy. I don't think it's ready to train a sentiment model by any means. What we're seeing is as you make progress towards removing these biases, it doesn't necessarily have to confuse the model itself. So that's my presentation. Thank you for listening. If you have any questions, I'm happy to answer them, and then I can check out the chat box afterwards to answer if we don't get to.